Question 11, we have a question with fractions, and we all love fractions. The secret to dealing with fractions is just to get rid of the fractions. So you want to find the LCM of the denominators. Look at 5, 2, 3, 4. We want to find the LCM of 5, 2, 3, 4. Now, what is the LCM? Well, the LCM is going to be a number that's divisible by 5, 2, 3, and 4 at the same time. So when I find the LCM, I typically use these numbers to find it. If I'm divisible by 5, I need to have a factor of 5 in my LCM. If I'm divisible by 2, I need a 2. And if I'm divisible by 3, I will need a factor of 3 to be divisible by 3. Now 4 is a little different. 4, I can actually factor that as 2 times 2. So I don't need to put a 4 here in my LCM. I only need one more 2. Because the previous 2 and this 2 makes it a 2 times 2 or 4. So we could use a 4, but it would not be the least common multiple. I want to find a number that's the smallest possible that's divisible by all 4 of these numbers. So I'm going to use a 2 here because we already have a 2 from the previous part to be divisible by 4. Now we can multiply all this out to get our LCM, and that's going to be 60. Now you could easily guess the LCM, and that's probably what most of you will do. You'll guess a number, and if it's divisible by all 4 of these numbers, then we can use it for the problem. What do we do with the 60? We're going to multiply that to each and every single one of our terms. So let's try that. I'm going to take 60 and multiply it by 3 over 5x. I have a negative here, so I'm going to just put that in the front. And then put 60 times 1/2 equals 60 times 2/3 x and 60 times 3/4. We're taking that 60 and multiplying it to every single term of our equation. Now it looks like we made the problem even worse, but it's actually going to cancel out all of the fractions, and that's what I want. 60 times 3 over 5, notice that the 5 and the 60 reduces. I could divide 5 by 5, I get a 1. 60 divided by 5, we get 12. We can multiply 60 times 1/2, reduce this to a 1, and 60 divided by 2 reduces to 30. We can also reduce 60 and 3, so that reduces to a 1. 60 divided by 3, that gives me 20. 60 divided by 4 is 15, and 4 divided by 4 is 1. So now we can just multiply across, so there should be absolutely no fractions if we pick the correct LCM. 12 times 3x, that's 36x. Negative 30 times 1, that's negative 30. Drop down our equal sign. 20 times 2x, that's 40x. And 15 times 3, that gives us 45. Notice there's no more fractions, so I know I used the correct LCM. Now we can collect like terms. On the left, I cannot add anything together. On the right, I can't add anything together. They are variables and constants, so we can't add them together. They're not like terms. So let's start by getting the x to itself. Let's subtract 36x to both sides. And at the same time, I can also subtract 45 to both sides, just doing 2 steps in one line to save some time. 36x and negative 36x cancels out. Negative 30 minus 45, that's a negative 75. That's equal to 40x minus 36x, that's a positive 4x, and 45 minus 45, that cancels out. We can now divide both sides by 4, And that's our solution. X equals negative 75 over 4. So practice this one again on your own. The secret is to find that LCM and multiply it to every single term. Question 12 is similar. I will find the LCM. But since there's a parentheses, let's distribute that parentheses or the 1/2 to the parentheses first before we begin the problem. 1/2 times 2x, well, that just simplifies to x. 1/2 times negative 7 is negative 7 over 2. And we'll bring down everything to the right. Now we can look for the LCM. I want to find the LCM of the denominators. In this case, we have a 2 and a 3. And we have another 3. But since it's the same number, we don't need to add any more numbers here in our LCM. So we'll start by building. What is divisible by 2? Well, it has to have a 2 in it. It also has to be divisible by 3. So we're going to include a 3. Now the reason we don't need that additional 3 is if I'm divisible by 3, I don't need to include that part in my calculation for the LCM. So the LCM in this case is just 6. It's divisible by 2 and 3 at the same time. And most of us could guess that it's 6. So go for it. Guess the LCM rather than multiplying out the denominators. So let's take that 6 and we'll multiply it to every single term, including those that are not fractions. Notice I have to multiply 6 times x, 6 times negative 7 over 2, 6 times negative 1/3, 6 times 4/3 x, and 6 times negative 5. We're going to multiply that 6 to every single term. Be careful and multiply it to every single term. Notice we have negative numbers here. So when I multiply everything by 6, I include that negative in the front just to make it a little bit easier to copy. So be careful if there's negative, just put that in front of your LCM or 6. Let's simplify now. 6 times x, that's 6x. And I could reduce 6 times 7 over 2. That simplifies here as negative 21. 6 times 1/3, that reduces to a negative 2x. 6 times 4/3 x, I can reduce. 2 times 4 gives us 8, or 8x. And negative 6 times 5, that's negative 30. Notice there is no fractions. That's because we picked the correct LCM. Now let's concentrate on collecting like terms. We have the 6x and the negative 2x. This adds to become 4x. Bring down the negative 21. And then we have equals 8x minus 30. After we simplify both sides, we can now subtract 4x to both sides, and I'm going to also add 30 to both sides just to save myself a little time. The 30 and the negative 30 cancels out, and the 4x and the negative 4x cancels out. Negative 21 plus 30 gives me a positive 9, and that's equal to 8x minus 4x, that gives me 4x. We can finally divide both sides by 4 to solve for x. Dividing both sides by 4, I get x equals 9/4. And that's our solution. Question 13, we're going to solve for x. We always start by getting rid of these parentheses. So let's distribute that negative. Pretend that's a negative 1 in front of that parentheses. So we have 7x, negative 1 times 3x, that's negative 3x. Negative 1 times negative 4, that's a positive 4, and that's equal to 4x minus 4. And now I'm going to collect like terms. Let's add the 7x and the negative 3x together. That gives me 4x plus 4 equals 4x minus 4. Now we're going to have to solve for x, so we're going to isolate the x. And something strange happens. When I subtract 4x to both sides, the x's completely cancel out. This gives me 4 equals negative 4. And this is not true. This is a false statement, or what we call a contradiction. This is a false statement or contradiction. So what does that tell me? Well, it tells me this has no solutions. So I'm going to write the symbol for no solution. It looks like a circle with a slash through it. Or you can write the word no solution. This problem has no solution because when we reach the end of our problem, we get a contradiction, which means there's no solution to this question. So be careful, if you get a contradiction, this means there is no solution. Let's check question 14 out. Let's see if we get something similar. Again, we're going to distribute. Don't forget, if you see a negative in front of the parentheses, distribute with the negative. So I have 5x. Negative 2 times 3 is negative 6. Negative 2 times negative 2x is a plus 4x. And that's equal to, we'll distribute with 3. I have 9x. And 3 times negative 2, that gives me negative 6. Then we can collect like terms. So I have a 5x here and a 4x. Let's add those together. That's 9x. Drop down that negative 6. And we'll copy everything we see on the right. So we're going to get something that might seem similar to the previous problem, but it's not. Let's start by subtracting 9x to both sides. When I subtract 9x to both sides, notice we get something that's different. We get negative 6 equals negative 6. This is not false. This is in fact a true statement. This is a true statement. So it's not a contradiction. This is known as identity. It's a true statement. It's in fact true always. So that means every single line of our equation was always true, no matter what x value we select. So in this case, when you get negative 6 equals negative 6 or something that's equal to the same thing, this is going to tell me that all real numbers is going to be the solution. So every single number that I plug in for x is going to yield negative 6 equals negative 6. It's always going to be true. So our solution is all real numbers. We sometimes use the symbol like this. It looks like a double script R for all real numbers. So you can write the phrase all real numbers, or you could use the symbol for all real numbers. In question 15, we're going to change things up a bit. We're going to solve absolute value equations. Now, what is the absolute value? Well, just recall that this is equivalent to the distance from 0 on the number line. That's our definition. The distance from 0 from the number line. So if we look at question 15, we want to find the absolute value of x equals 2. So if I draw the number line, we have a 0 in the middle, and we have 1, 2, 3 on the right, and on the left side we have the negative integers, negative 1, negative 2, negative 3, and so on. So it goes forever in either direction. What I'm asking here is, what x value will yield a distance of 2 from 0? Well, if you check, x could be equal to 2 and the distance would be 2 from 0. Or x could be negative 2. If you look at negative 2, I still have a distance of 2 from 0. So the distance from 0 is 2 if x equals negative 2 or positive 2. So there's actually two solutions to this problem. X could be 2 or x could be negative 2. And that's from the definition. We want the distance to be 2 from 0 on the number line. So there's usually two answers for absolute value equations. Usually two answers. Not always, but usually two answers. So to solve question 16, we're going to use the previous problem to justify the steps in question 16. Now the previous problem was the absolute value of x is equal to 2. Now we had two solutions. We said that x could be equal to 2 or x could be equal to negative 2. Now in this case we have x plus 6 on the inside rather than just x. So this changes the problem slightly. The x on the inside is known as the argument. And the x plus 6 here is also known as our argument. So what we're going to do is we're going to compare that to the previous problem and break it up into two equations just like we did earlier. So what we're going to say here is I can say x plus 6, well that's got to be equal to 13, or I can say x plus 6, well that could be equal to negative 13. If the inside is 13, well the distance from 0 has got to be 13. If the inside is equal to negative 13, well that's the same thing. The distance has to be equal to 13 also from 0. So I have to create two equations when I'm talking about an absolute value. And then we can solve each one separately. And that's why we usually get two solutions. So we'll subtract 6 to both sides. We'll subtract 6 to both sides of the equation. And I get x equals 13 minus 6. That's going to give us a positive 7 as a solution. We'll subtract 6 on the other equation as well. And this gives us x equals negative 19. We have two solutions. We have negative 19 as one solution and 7 as the other. So two solutions for this problem. Question 17. Try this one on your own. Break it up into two equations. Now to do this problem, I'm going to take the argument, whatever's inside the parentheses, and I'm going to set it equal to 20. 3x plus 2 equals 20. Because if I take the absolute value of 20, well the distance is equal to 20. Or the inside, or the argument, could be equal to negative 20, and the distance will still be equal to 20. Again, we have two equations. So set the argument, or the stuff on the inside, equal to 20, or negative 20. So we'll subtract 2 to both sides here. 3x equals 18. Let's divide both sides by 3, and I get x equals 6. So that's our first solution, x equals 6. For the other side, let's subtract 2 to both sides, and I have 3x is equal to negative 22, and I can divide both sides by 3. Let's divide both sides by 3. X equals negative 22 over 3. This is our two solutions, so I'll write it in curly brackets, negative 22 over 3, comma 6, and we'll close that curly bracket. Question 18 is a little bit harder, so my tip for you is to isolate the absolute value symbols. Get that by itself first, then write your two equations. don't write your two equations first. You first have to isolate the absolute value. So that's very important. I'm going to start by subtracting 15 to both sides to isolate that absolute value term. This gives me the absolute value of x minus 8 is equal to 21 minus 15, that's 6. Now notice, since the absolute value is isolated, we can rewrite our equation. Now there's two possibilities. Either the inside is 6, that will yield an absolute value that will give us 6, or if x minus 8, the inside is equal to negative 6, the absolute value is still going to give you 6. So there's two equations. And we can easily solve both of these equations by simply adding 8 to both sides. And now my first solution is x equals 14. For the second solution, we have x equals a positive 2. Our first solution is 2, and our second solution is 14. So the tip here is to isolate that absolute value first, then you can split it into two equations. When you split it into two equations, make sure to remove the absolute values. Question 19, again, isolate that absolute value, get it by itself, then write two equations. So let's add the 15 to both sides. We have the absolute value of 2x minus 7 is equal to negative 6 plus 15, that's a positive 9. Since the absolute value is isolated, now I can set the argument equal to 9. If the absolute value of 9 is taken, we get a distance of 9. Or if the inside is equal to negative 9, the distance is also equal to 9. So we have two equations, removing the absolute value, and we can solve each one separately. So let's take some time. We can add 7 to both sides here. That gives me 2x is equal to 16. We'll divide both sides by 2. X is equal to 8, and that's our first solution. For the other side, we'll add 7 to both sides. And so we have 2x is equal to negative 2. I can divide both sides by 2. And we get x equals negative 1. So that's our second solution. Now you can check your work. You can plug in the 8 for the x and make sure the equation is true. And then you can try the same thing with negative 1. So you can always check your work for these problems if you have time. Alright, but let's write our answer. We have negative 1 as our first solution and positive 8 as our second solution. For question 20, it is very similar to the previous questions, just with more steps. So the goal here is still to isolate that absolute value, get it by itself. So I'm going to add the 5 to both sides, and we have 2 times the absolute value of 3x plus 1 is equal to 44. This 2 is actually multiplied to the absolute value. So some people might feel tempted to distribute the 2, and that's actually okay to do. But you can only distribute if you use a positive number. Use a positive number if you plan on distributing into the absolute value. But I'm going to actually choose to get rid of the 2 in a slightly different manner. I'm going to divide both sides by 2 so I don't have to distribute. And that cancels out that 2 here. And now we can simplify 44 over 2. So we have 3x plus 1 in absolute value is equal to 22. Now the reason I chose to divide both sides by 2 is I'm trying to isolate the absolute value. It just makes more sense to me to keep it simpler, so it's easier to divide both sides by 2 rather than to distribute. Now I could write two equations. I could set the inside here equal to positive 22, or I could set the inside equal to negative 22. You can only separate into two equations after you isolate the absolute value. Don't do it in the very first step. That's not possible. So let's subtract 1 to both sides. We have 3x is equal to 21. I can divide both sides by 3. And x equals a positive 7. That's our first solution. I can subtract 1 to both sides. We have 3x equals negative 23. I can divide both sides by 3 now. And you have x equals negative 23 over 3 as our second solution. So we could write our solution in a set of curly brackets again. Typically I put the lower number on the left and then the larger number on the right, but it doesn't really matter. The order doesn't count. In question 21, some people might feel tempted to distribute that negative into the absolute value of x plus 6. Don't do it, it will not work out. In the previous problem, we could have distributed a number into the absolute value because it's positive. For example, if I have the absolute value of 3, well, that's going to give me a 3. If I ask you what's 2 times the absolute value of 3, well, I can take the absolute value of 3, which is 3, and then multiply it by 2, I will get 6. If I distribute the 2 into the absolute value and say, hey, that's equal to 2 times 3 in absolute value, yeah, that's still 6, so it works if it's a positive coefficient. If I consider, however, negative 2 times the absolute value of 3, I should take the absolute value first, which is 3. So negative 2 times 3 gives me negative 6. So negative 2 times the absolute value of 3 is negative 6. If I were to make the mistake of trying to distribute that and say that's equivalent to negative 2 times 3 inside an absolute value, that would be equal to the absolute value of negative 6, and that is equal to 6. So these two are different. So don't distribute into the absolute value unless it's positive. If you have to, use a positive number. But in most cases, I try to avoid distributing into an absolute value. We first have to isolate the absolute value, so I'll add the 5 to both sides. Negative absolute value of x plus 6 is equal to negative 4. Now again, I don't want to distribute, I'd rather get rid of it using division. So let's divide both sides by negative 1, because we could pretend there's a negative 1 in front of this absolute value. The negative 1 and the negative 1 divides out. So I have the absolute value of x plus 6 is equal to a positive 4. Negative 4 divided by negative 1 is a positive 4. Now I can write two equations. Set the inside equal to 4, or the inside could be equal to negative 4. Only set into two separate equations if you can isolate the absolute value. Again, isolate that absolute value. We can solve for x now. I can subtract 6 to both sides, and we'll get two solutions. X equals negative 2 is our first solution, and x equals negative 10 is our second solution. So we'll write my answer as negative 10 comma negative 2 in curly brackets. In question 22, we have two absolute values. So the goal is always to isolate the absolute value first, and in this case, we have two. So we're going to have to do something a little bit different. There's two possibilities. We have one possibility is the arguments are equal to one another. So let's say x plus 12 could be equal to 2x minus 9. So if they're both positive, well then they could be both equal to the same number. Or if they're both negative, this would also be true because the absolute value is going to give us a positive number. So that's one scenario. The other scenario is if the first number is positive, well, the other one could be the opposite. It could be the other number is opposite. It's negative 2x minus 9. So in the first scenario, they have the same sign. Either they're both positive or both negative. And in the second scenario we have here, one is positive and the other one is the opposite sign. Or it could be this one's negative and this one's positive. We don't know. So the second scenario is when they're opposite in sign. So let's get started. Let's try the first equation. Let's subtract x to both sides, and we'll also add 9 to both sides. This cancels some terms out for us. And so we have 21 is equal to x, and that's our first solution from the first equation. For the other side, we'll have to distribute that negative 1, and since this is a parentheses, we can do that. We'll pretend this is a negative 1, and this is x plus 12 equals negative 2x, and negative 1 times negative 9, that's a positive 9. We'll collect like terms. I'll choose to add the 2x to both sides just to keep my variable positive, and we'll subtract 12 to cancel out that 12. We have negative 2x and 2x also canceling out. On the left, x plus 2x gives us 3x. On the right, we have 9 minus 12, which gives us a negative 3. We'll divide both sides by 3, and x equals negative 1. Our two solutions, negative 1 and 21. So in this case, if there's two absolute values, we'll set the arguments equal to each other for the first scenario, and for the second scenario, set the absolute value equal to its opposite on the other side. And that's how you solve absolute value equations when there's two absolute values. Question 23, it's another solving problem. So we'll start by isolating that absolute value. Always isolate the absolute value. So we'll subtract 14 to both sides, and then we'll see what's left. This simplifies to x minus 6 in absolute value, and that's equal to negative 5. Now a lot of people might think, okay, I got to separate this into two equations. X minus 6 equals negative 5, or x minus 6 equals positive 5. That is completely wrong. That is completely wrong. You don't do that. Why don't we do that? Well, look on the right side. This is a negative. When you see a negative on the right side, I want you to be cautious. Let me ask you this question. When is the absolute value of a number going to be negative? When is the absolute value of a number negative? Well, what's the definition of the absolute value? The absolute value of a number is, by definition, the distance from 0. So, when is the distance from 0 negative? Well, that's not possible. So when you have the absolute value equal to a negative, well, that means there's no solution. This is not possible. The absolute value is the distance from 0. We can't have a negative distance from 0. So this gives us a no solution.